The next thing we're going to do in this chapter is talk about what's called function notation. And function notation is kind of like learning new words. It's a more advanced way of saying equation. It means something more powerful. So when you were a little kid, you would say, it was nice, and she was nice, and they were nice, and I was nice. You now use more descriptive words like polite and friendly and kind. So you don't use the same word over and over. You use more advanced descriptive words. That's kind of like function notation. It's another way of saying why. So the way that we read that, though, is we don't read f parentheses x. What it stands for is the value of f at point x, or f of x. So we read this thing right here, f parentheses x. We don't say it that way. When we see that, we say f of x. One important thing to note is that the parentheses do not mean multiplication. It's not f times x, it's f of x. You might also see other letters, like it might say g of x or h of x, and we'll talk about when you would see those later on. We talked about y equals mx plus b equations. Now, instead of y, we can use f of x. So this says the exact same thing. F of x equals mx plus b. This tells me that x is my input variable, my domain, my independent variable. So we always like to keep it nice and simple in example 1. We're going to evaluate f of x equals negative 4x plus 7 when x is 2 and x is negative 2. So all you do is you take 2 and you pop it in for x, and you see what you get, and then you do that with negative 2. So here's what I wrote. F of negative 2 equals negative 4x times negative 2 plus 7. Just like equations, wherever you see an x, you put a negative 2. This is saying I'm evaluating this function f for the number negative 2. So now we just calculate, and I don't need to kind of show all my steps. F of negative 2 is equal to 15. Now you do it again with negative 2. Oh, sorry, positive 2. I did it in reverse order. So f of positive 2 is equal to negative 4 times 2 plus 7. So f of 2 is equal to negative 1. Now we're going to just say what it means. What does function notation mean in the context of a story? So f of t is the outside temperature t hours after 6 a.m. Explain the meaning of each statement. So f of 0 means 0 hours after 6 a.m. So what time is it 0 hours after 6 a.m.? It's 6 a.m. So at 6 a.m., it's 58 degrees. All right. F of 6 means 6 hours after 6 a.m. It is n degrees. So it's some mystery number of degrees 6 hours after 6 a.m. So what time is that? That's noon. So at noon, it is n degrees Fahrenheit, because we don't know what the value is. And then the last thing says f of 3 is less than f of 9, so the temperature 3 hours after 6 a.m. is less than the temperature 9 hours after 6 a.m. So you do the math, and that means that 9 a.m. has a lower temperature than 3 p.m. Now this one is kind of giving us, in example 3, the answer in a sense, and we have to find out what the value of x is. So if you notice, they gave us h of x, and the reason that they changed the letter is just because they wanted to show that it's a different equation. Sometimes if we have multiple functions in the same story, we use different letters, so this is just an example of why they would switch letters. So h of x is negative 7, so we're not going to plug it in for x, we're going to plug it in for h of x. So here's what it looks like. Negative 7 equals 2/3 x minus 5. That's an equation straight out of chapter 1. So I'd like you to pause the video and solve the equation. So here we go. I hope that instead of dividing by 2/3 or dividing by 0.6 or dividing by 0.66, you remembered from 7th grade to multiply by the reciprocal. So if we have a fraction 2/3, we're not going to divide by 2/3. We're going to multiply by the reciprocal, which is 3/2. And that entirely cancels out this fraction. And then when you multiply over here, you get -6/2, which is -3. All right, next thing that we're going to do is we're going to graph these functions. Now, remember, the functions are just y equals mx plus b. So the way that you graph any sort of equation, no matter what it is you always make a table of values. So I'm going to make a x, then I'm going to write my equation, f of x equals 2x plus 5. Then I'm going to find the y value, and then I'm going to plot it. So you should always pick a negative, a positive, and 0. Those are like the 3 important pieces to plug in. You can plug in other numbers too if you want, but I always like to do a negative, a positive, and 0. So I'm just going to pick some random numbers. I'll do -2 as my negative. Obviously 0 is 0, and then I'll pick 1 as my as my positive. You always want to keep your numbers kind of small, because if you get to pick the numbers, you want to make the calculations very easy for you. So what this middle column tells me to do is it tells me to plug in my values. So what I do in the first one is I'll do 2 times -2 plus 5. So I do all the calculations, number crunch that, and I get 1. Then I go to the next row, 2 times 0 plus 5. I crunch that in my head because it's very easy. Hopefully I don't need a calculator, and you get 5. And then I do 2 times 1 plus 5, and that's 7. So the points that I'm going to plot are -2, 1, 0, 5, and 1, 7. So let me make a grid. Now this is a little different than the other ones that we were graphing recently because I need all 4 quadrants. It's not going to be a first quadrant graph because I have negative numbers. So I'm going to go right, well, that's very crooked. I'm going to do my best to go nice and straight. Hopefully if you're at home you have a ruler. And I'm going to make a grid. Let's kind of put it down here because I know I need to go all the way up to 7. Hopefully I can fit. Oh, perfect. Okay. I label that X, I label that Y, and now I plot my points. So I'm going to plot -2, 1. I'm going to plot 0, 5. And I'm going to plot 1, 7. You connect them. That was very crooked. Hold on. Took me a couple tries because I was on the computer. And then the last thing you want to do is you want to write the name of the equation next to the line. So f of x equals 2x plus 5. And that's how you graph a function. You make a table, you plug in numbers, and then you plot them. All right, last example. Pause the video, read the story, and then press play when you are ready. All right, so I circled and underlined the step number 1, which is understand the problem. We have the graph of the first flight and an equation of the second flight. And what they want us to do is to compare the flight times to determine which flight takes less time. The plan that I want to do is to take this equation, make a little chart, plug in some values, and I want to graph it on this grid. If you can make the table by yourself, do that, pause the video and graph the line using the setup of the table that we used above, or if you're not sure, wait until I pop up my table. All right, there's my table. If you need to copy mine down, pause and check it out. If not, let's go and graph. So I go through the point 0, 350, so I'm going to put a nice dot right there. It's 0, 350. Oh, I should use a different color than blue. Okay, 0, 350. And I also have 1, 225. So that's kind of like right there, maybe. And I also have two 100. Oh, they both have two 100. So then I just quickly connected them, and I saw that the second flight gets me in a little faster than the first flight. The second flight hits it right before 3 hours, whereas the first flight takes 3 hours. So the last thing that we have to do is say which flight takes less time and explain. So it's going to be the second flight because it hits 0 miles faster based on the graph. What you can do to do step 4, which is to look back at the problem, you can actually calculate when it equals 0 miles. So you take the equation 0 equals 350 minus 125x, and several inverses later, you'll get that x equals 2.8. And so it would actually hit at 2.8 hours, which could be the way that you confirm that the second flight takes less than 3 hours. If you have any questions, write them down and ask me when you come to class.